not mistaken, this is a pretty important lesson that gets used quite a bit throughout the year. So hopefully we get this. So how can I use slope and a point to write an equation? So writing the equation of a line given the slope and a point. To do well in the big race, you had to write the equation of a line with a given rate, slope, that passed through a given point. Your method probably involved estimating the y-intercept of the line visually or working backward on a graph. What if the given point is far away from the y-axis? What if the estimate is not good enough in a particular situation? So during this lesson, you will develop an algebraic method for writing the equation of a line when given its slope and a point on the line. And it's actually pretty easy to do, but we have to make sure that we kind of understand what's going on here. So Colleen recently purchased a farm that raises chickens. Since she has never raised chickens before, Colleen wants to learn as much about her baby chicks as possible. In particular, she wants to know how much a baby chick weighs when it is hatched. To find out, Colleen decided to track the weight of one of the chicks that was born just before she purchased the farm. She found that her chick grew steadily about 5.2 grams per day, and she assumes that it has been doing it since it hatched. So M equals 5.2. 9 days after it hatched, it was 98.4 grams. So think about that. That's a XY, right? We know X is going to equal days, and we know Y is going to equal weight. So they're telling us that in day 9, that thing weighed 98.4. It says determine how much the chick weighed the day it was hatched using two different methods, a graph and the XY table. So let's think about this. So first of all, let's do the XY table. We know that we don't know 0, 1, 2, 3, 4, 5, 6, 7, 8, but we do know 9 is 98.4. And we do know that every time we go up, we can subtract 5.2. So that would be 93.2 on day 8, because it grew 5.2. So if you add those together, that would work. It would have been at 88 here. Here, I think it would have been at 82.8. 83. Okay, so here, 0.6. We're gonna say 77. I always struggle with this. 72.4. 67.2. And again, I'm just subtracting this 5.2 each way back, right? So this would be 62. So then this would be 56.8, I think, and 52.6. So I'm coming up with the equation y equals 5.2x plus 52.6. And what I would want to do here is plug in day 9, because I know day 9 should give me 98.4. So I'm going to check my equation. 5.2 times 9 plus 52.6 should equal 98.4 if I'm right, and I'm wrong. Okay, so obviously I was off by, I think luckily I was, how lucky. Just right there was where I was off. That should be 51.6. I think if I plug 1 into my equation, 5.2 times 1 plus 52.6, 50, oh no, I was off right there as well. Gosh dang it. So now the question is, where did I screw this thing up at? So let me pause and go through and find my error. God dang it. Just didn't change the 51.6 here. So it was right there. Oh boy. You know, sometimes it's not good to not be very bright. All right, so this should be 51.6. This should be 51.6. You know what? If I had more shame, I would delete all this and start this video over, but I do not see myself doing that. Okay, so we get something that looks like this. Now, if we were to, and I don't really see myself going to this much trouble either, but if I was on day 9 and I was at 98.4, right? They wanted us to graph, and if I go graph back, you can see that it will end up on day 0 at 51.6. So there's my poor graph, but let's pretend that's what it was. So assuming the chicken will continue to grow at the same rate, determine when the chick will weigh 140 grams. All right, so I have my graph poor, and I have my XY table. Ultimately ended up being right. So I came up with this equation, and now they're saying, how old will the chick be when it weighs 140 grams? Well, think about that. Are they asking how big it'll be on the 140 day? They're not. They're asking when it will weigh 140 grams. So I'm going to plug that in as the output. I'm actually going to work backwards and solve for the input. So I'll subtract 51.6 from each side there. I'm going to get 140 minus 51.6. I get 88.4. I'll divide by 5.2. And you can see that is going to happen on day 17. Day 17, this chick should weigh 140 grams. And again, if we want to verify that, we'll just say 5.2 times 17 and add 51.6, and we'll make sure that we land on 140, which we do. So we feel pretty good about that. All right, now we get into some further guidance, which basically helps us make the graph and the table that we just did here. So I'm going to get out of this and open up the next thing and see where we're at here. So we have our further guidance. Again, this is sort of helping us come up with the table. Now we're done with the further guidance, so let's see if I can open up C and be on problem 290 or not. So let's close here and see if I'm on 290. There we go. All right. So continuing along here, it says writing an equation without a table or a graph. So you can see that was a pain, right? The graph was so bad I didn't even feel like doing it. And the table was a pain and I screwed it up because I wasn't using a calculator. So let's go ahead and say, how can we solve this thing another way? And essentially it's going to talk us through what we're going to discuss right now, but I would rather just sort of take over from here and go with this. So we were at day 9 of this thing being 98.4 grams, I think it was. And we know that the slope was it was gaining 5.2 grams a day, right? That was our slope. So if we think about this, y equals mx plus b. I can solve anything if I know I only have one variable missing. So here's what I mean by that. This is very simple. I'm only missing one variable. So x must equal 3. However, this is a lot more tricky, right? Because it could be 10 and 0 or 9 and 1 or 8 and 2 or 11 and -1 or 10 and a half and -1/2. So if I have two variables, I can't solve it. But if I only have one unknown variable, I can solve it. Well, if I look at this, I only have one unknown variable. I have an x, I have a y, and I have an m. So for y, I'll substitute in 98.4. For m, I'll substitute in 5.2. For x, I'll substitute in 9. And my unknown variable happens to be b. I don't know what b is, but I do know what everything else is. So I will grab my calculator. I will say 5.2 times 9 is going to equal 46.8. I'll subtract 46.8 from each side. At this point, I'm getting anxiety because I'm worried that I guessed these numbers wrong. I was going by memory, and I'm hoping I didn't screw this up. 98.4 minus 46.8 equals 51.6. And I think that ended up being our y-intercept. So here's what we have. We have an m and a b. And that's all we need to write the equation of our line. I'm going to say y equals m is 5.2 x plus 51.6. A good way to check this is I do remember day 17 should have equaled 140. So let's plug 17 in and make sure I have the right equation. 5.2 times 17 plus 51.6, praying that this equals 140, and it does. So good, I did remember the right number. So that's the trick, and that's the shortcut that we're going to use to solve these. So really big deal that we know that. So again, we have some other ones here. We have a slope of -3 that passes through point 15, -50. Well, here's my m, here's my x, here's my y. So I will go y equals mx plus b. I will say my y is -50, my m is -3, my x is 15, plus b. That's my unknown. Again, I can have one unknown. So -50 equals -45 plus b. I'll add 45. -5 equals b. I already have my m. So my equation is y equals -3x minus 5. If I plug 15 in, I should get -50. -3 times 15 is -45, minus 5 is -50. So that equation seems good. Clear this off and do the same thing here. My m is 0.5, my x is 28, my y is 0. So I will say y equals mx plus b, y is 0, m is a half, x is 28, plus b is my unknown, so half of 28 is 14. If I subtract that, I get -14 equals b. I already have my slope, so I get y equals 0.5x minus 14. And again, if I plug 28 in, I expect to get 0. Half of 28 is 14. 14 minus 14 equals 0. So this strategy definitely seems to work, and we definitely need to know this strategy. So please do not forget that strategy. Make sure you spend some time working on it. The Earth's surface is composed of gigantic plates that are constantly moving. Currently, India lies on a plate that is slowly drifting northward. India's plate is grinding into the rest of Asia. As it does so, it pushes the Himalayan mountains, which contain the world's highest peak, Mount Everest. In 1999, mountain climbers measured Mount Everest with satellite gear and found it to be 8,850 meters tall. So in 1999, it was 8,850 meters tall. Geologists estimate that Mount Everest is growing by as many as 5 centimeters a year. Oh, they're killing me. So did you see here that this is in meters and that this is in centimeters? Ugh. So I have to convert this. I think there's 100 centimeters in a meter, right? I'm going to make sure I have this right. How many centimeters in a meter? I think it's 100. Yeah. All right. I just want to make sure I didn't screw that up at the end of this video. So 5 centimeters is how many meters? Let's do some dimensional analysis here, right? So how many meters is 5 centimeters? Well, I know 1 meter equals 100 centimeters, and I know that I have 5 centimeters, so those will cancel out. I get 5 divided by 100, 5 on top, 100 on bottom. I get 0.05 meters. So this equals 0, my slope is 0.05 meters. So geologists estimate it may be growing as 5 centimeters a year or 0.05 meters. Assuming a constant growth of 5 centimeters a year, determine how tall Mount Everest was in year 0. So we need the y-intercept. So write the equation over time, right? X and y. So not too bad. Just got some big numbers to work with here, but seem to be on the right track, especially with that unit conversion. I think was a big deal there. Catching that before we got too far into it. So y equals mx plus b. My y is 8,850. My slope is 0.05. My x is 1,999 plus b. So I'll grab my calculator and I will say 1999 times 0.05 is 99.95. So 8850 equals 99.95 plus b. So you can see apparently Mount Everest has grown really close to 100 meters in that time. I'll grab my calculator. I will get 8850 minus 99.95, and we'll get 8750.05. So our equation will be y equals 0.05 meters plus 8750.05, which means in year 0, we think Mount Everest, was 8,750.05 meters. Maybe you should get rid of this. As a matter of fact, I should tighten that up, I think. Let me jump over here and make sure I get the right answer for that. I'd hate to do so much of this video and then end up being wrong at the end of it. So it was like 80, what did we get? 8750.05. 8750.05. So looks good. Again, that strategy of substituting in for the y, the m, and the x and solving for the b.